Wait, you can send, one of them can send them to you.
Awesome.
Okay. So, hello everyone. I think you know my name, but it's okay if you don't.
Guys, what's his name?
Yeah, I'm sure how we. Okay, so today we're gonna be doing something a bit different from yesterday. It's called the heap, but it's kind of like very separate from the stack. So like, if you didn't really understand anything from last time, it's okay. But basically, the heap, we'll be going through these things, like certain mechanics of the heap, how it works, and then how we can actually exploit it. Yeah. So first, right, what is the heap? So you know when you're like queuing for Caesarea, right? And you're queuing outside Caesarea, and there's like this waiter. She's going down the queue, and she's asking like, oh, how many people? And you say 2, and the guy behind you they say 3, and the guy behind them they say 4, right? And you know what they do is like they'll take the guy who has like the correct number of people, right? Because there's like a free table with that number of seats, and then they'll give that table to that guy, right? So in a way, the heap is kind of like Caesarea, right? Because when you have a table that has the correct number of seats, and someone is asking for that number of seats for that number of people, right? You can just give that table to that guy, right? And when that guy leaves that table, you immediately know that that table is already free. So the next guy that has the same number of people, you can just give that table to them. So this is what's called kind of like the stack is the first in, first out, right? Whatever that you free can immediately be reused. Another thing is that you know how in Caesarea when they have like a really big number of people that they want to service like a table for, right? And sometimes what they do is that they have like two tables next to each other that have, let's say, 4 seats each, right? And the guy wants like 8 seats. So sometimes they can like combine the 2 tables together, and then they'll give that table to that guy. And this is something that you'll see later called consolidation. And it's when you can like merge like memory in the heap. Okay, but in technical terms, like what exactly is the heap, right? Oh wait, did I record? Shit. Yeah, it's recording. What is a heap? Basically, it is like a dynamic memory structure, right? For things that you need a lot of space for, and you don't know how much space it is, right, at runtime. The heap is something that we're gonna use to allocate that kind of space for, right? And this is usually used for managing like dynamic data structures, for example, like linked lists for anybody who know those, and yeah, you know, large allocations. So to give you kind of like a visualization of what goes on in the program when you're using the heap, right? What happens is that the user is gonna call this function called malloc, right? And it's gonna pass in a number to malloc that denotes like how much space exactly that they want, right? And inside the heap, there's gonna be this memory, this large pool of memory, right? Like a memory region, kind of like the stack, but it's a bit larger also. And you have this chunk that's called the top chunk, right? And what this exactly means, you can kind of see. So when the user requests like an amount of memory, that amount of memory is gonna be broken off the top chunk, right? So initially you have this large chunk, and then when it requests memory, you take off like the top of that chunk, and after that the top chunk like moves down below the memory that is requested, right? And you can see over here that for each chunk in the heap, there's a certain piece of metadata that denotes exactly like how big it is, right? So for example, over here, you notice that the user requested like hex 30 bytes, right? So it's gonna return hex 30 bytes, but there's gonna be an additional hex 10 bytes dedicated for this metadata. And the size over there, you'll notice that it's hex 40 instead of hex 30, because the extra hex 10 is the space allocated for the metadata. Okay. So these are just some things to take note of how like the heap looks. And basically, the full like deconstruction of how the chunk actually looks, right? You have the size header, and then you also have the actual usable space, right? So when the user requests a chunk from the malloc or from the heap, it's gonna return the address of just below the size header over here. But the size header is gonna contain like some important numbers, right? For example, the size itself is gonna be this 64-bit number, and there are gonna be some like bit flags, which are like certain bits at the start of the number that denote what kind of chunk it is. Usually, the most common one is gonna be the one at the end that's enabled, so the P bit, right? Usually, you will see that it is set to the value of 1, right? And that's about all you need to know. Actually, the other bit flags, they're not quite important at this stage. So once the heap has managed to like break off a chunk of memory to return to malloc, right? It's gonna take the pointer to the start of the usable memory over here, right? And that pointer or the address is gonna be returned back to malloc, which is gonna be returned back to the app, right? And then, yeah, the user is gonna be using it for some whatever purpose that they're using it in the app. Okay. And what happens when the user like doesn't need the memory anymore, right? So it's gonna call this function, which is like free, and it's gonna pass in the pointer or the address of that piece of memory to the free function, right? And then what it's gonna do, kind of like you remember in the restaurant, the waiter remembers that the last free table was just like given back to the restaurant, right? This is kind of like in a way remembering what the last free chunk is. So it's gonna like take this chunk and it's gonna link it into what we call a bin, right? And what a bin is basically like a long list of free chunks that have the same size, and this is denoted by the size of like the bin, right? So if let's say the app like requires the same number of bytes or the same amount of memory again, right, and it passes it into malloc, what the heap is gonna do is it's just gonna return the first free chunk in that bin, because it knows that it was used before, so it can just give it back again instead of breaking it off the top chunk. Okay, so that was a lot to take in. Does anybody have any questions? Or do you get like okay. So the big idea is basically the free list is kind of like a last in first out kind of data structure. So kind of like the stack, whatever you put in last, right? When you take from it, it's gonna be the last one, right? So kind of the certain questions that you're gonna want to ask in heap exploitation is gonna be like these two. So these are gonna be the two like important ones that you wanna concern with, right? For example, right now we have this idea that whenever we allocate memory from the heap, right, we're gonna be writing data within that chunk itself. But another question is like, what happens if you have a kind of like an overflow situation? Like in the stack, right? What happens if you can write data past the chunk? So that is one of the parts of exploitation. Another part of exploitation is also, if let's say you free the chunk, right? Usually the logic is that once you free a chunk, you shouldn't be able to use that chunk anymore, right? Because you don't need it anymore. It's already been given back to the heap. But what if, let's say, somehow you keep the address or the pointer of that free chunk in memory, and you somehow still manage to use it? So what happens then, right? And that's another like essential problem in a heap exploitation, basically. Okay, but before we can do any sort of exploitation, we kind of have to understand how exactly the heap works, right? So what exactly goes on when we allocate chunks from the heap? What happens when we free chunks from the heap? Or the exact mechanics. So when you free a chunk, right? And the program is like done using that allocated chunk. Basically, like I said, it's gonna be placed into the bin that matches its chunk size. So in this example, we use a hex 40 bin, right? Because you have like a lot of chunks that are hex 40. And basically, you want to find a place where you can remember all the addresses of this hex 40 chunks, right? And then when you need the same size again, you can just take from that list, right? And that's basically what a kind of a bin is. And in the glibc heap, or what we call the libc like library, right? The way it manages like the bins for the free chunks is it uses multiple types of bins. For example, there's the Tcache, which we're gonna be talking about more so this today for exploitation. And then there's also like a few other bins called like the fast bins, the unsorted bins, small bins, and large bins, right? So at a glance, these are all the bins in the heap. Now for the Tcache, right? So there are multiple like bins for each size, but also for each thread, there's gonna be like a separate Tcache, kind of, for each thread. You don't really need to know what that means, but yeah, it's just good to know. And then for each bin, right, it's gonna be like a list of chunks. So for the Tcache, it's gonna be 7 chunks in one bin. And the fast bin is kind of like the Tcache, but there's no limit to how many chunks can be in one bin. The unsorted bin is like when it doesn't fit into the Tcache or the fast bin, it goes into the unsorted bin, right? And it does not have a fixed size like in the Tcache, because you're gonna have like one whole bin for a range of sizes, right? And then basically they're like doubly linked, and after a certain large allocation, what the heap is gonna do is it's gonna sort the chunks in the unsorted bin and place them into the corresponding like large or small bins also. So for example, if let's say in the unsorted bin you have a very large kind of chunk, during sorting, that large chunk is gonna go into the large bin, and similarly for the small chunk into the small bin, right? But all you need to know is that for the unsorted bin and for the large bin and small bin, usually they contain libc pointers, which is very useful if we want to leak libc, right? And yeah, so since there are like so many bins, basically there's a certain checklist that the free function goes through to decide how to allocate the chunk, right? So if the chunk is small, it's gonna go into the Tcache, and if the Tcache is full, it's gonna go into the fast bin, and if so, it's just gonna go into the unsorted bin, right? And yeah, when you make like a really large request, it's gonna try to sort the chunks in the unsorted bin and so on. So to kind of give like another visualization, let's say we go back to the example where this guy doesn't need this chunk anymore. It's gonna free it, right? So it calls the free function on the address, and what the libc is gonna do is it's gonna like link the chunk into the bin. And how it does this is let's say this is the bin, and when it's empty, the head of the bin is gonna be like a null pointer, right? So in the chunk, the first like number in the chunk is also gonna be a 0 or a null pointer, right? And to link the chunk into the bin, like what exactly it has to do is that basically you gotta get the head of that bin to point to the address of like that chunk. So yeah, and after that the count is like 1, right? And when you free like another chunk, it's gonna add that address to the top of the bin list. So it's gonna link it at the head, and then the count will be 2, right? And basically what this looks like in like the memory is that the chunk that you just freed, right? This blue chunk over here. The first number of that blue of that blue chunk is gonna be the address of the previous like the previous head of the bin, kind of, yeah. So in general, right, when it's gonna free the chunk, basically the kind of like pseudocode is that it wants to set the head pointer of the bin to the next like chunk that you free into the bin, kind of. Yeah, and then after that you'll increment the count and so on. And then similarly, when we want to take from the bin, right, what it's gonna do is that it's gonna find what address is at the head right now, right? So first it checks for the count, and it sees that the count is like is greater than 0, right? So it can just take from the bin instead of allocating from the top chunk. And kind of what it does is that it takes the address that's already inside the head, right? And it's gonna wanna unlink it from the bin. So first, it needs to make sure that the linked list itself is not kind of like destroyed when we take out the chunk, right? So it's gonna want to take the address of like the next chunk, right? And then it's gonna link it into the bin, so that the list like is preserved, kind of. And then the old like head pointer like inside the bin is gonna be returned to the malloc function and so on. Okay, we just like breezed through a lot, and I think I kind of rushed through it. But okay, any questions for now? Kind of. I know it says lunch. Technically we still have a lot of time. It's only 9 a.m. Okay. Okay, wait. So yeah, what's up?
What does malloc mean? Like the full meaning of malloc.
Oh, so malloc is like it's just a shorthand for allocate, right? Yeah. So if let's say you want to use stuff from the heap, you're gonna want to use malloc and free, and malloc gives you the memory from the heap, free returns memory to the heap, kind of. Okay, wait. Any questions? Maybe I can show you guys like an example in the okay. So just to give you guys an example, you can download like this challenge. I think it's not up yet. Oh my god. Okay, I'll just show you guys here then. Oh yeah. Yeah, okay. Wait, so if let's say I was writing like a C program, right? Let me just set up like the usual like headers and stuff. Okay, so pretend that I'm writing production code, and for some reason I want like a large like kind of allocation from the heap. So what I would do is kind of like use malloc, and I would pass in like the amount of bytes I want from it, right? Okay, let's say hex 100 bytes. I'm gonna put a get car over here so that we know we can like debug later, but okay. So at the start of the program, right, the heap is not gonna be initialized at all. Okay, wait, what? Wait, the vbuff. Oh, right. Okay, this is just like some initializer stuff, so it looks correct. So before the program runs, the heap is not gonna be what? Wait, did I compile? Oh, okay. So at the start the heap is not gonna be initialized, right? But you can see over here that okay, wait, yeah, the memory region hasn't been allocated yet. So upon the first allocation, right, by malloc, what it's gonna do is that it's gonna create the whole like memory region, and it's gonna like create this like memory region, and then you see that it's like denoted by the heap label here, right? And if I do this like command, you can see that there's this top chunk over here. There's this like really large chunk that fills up the rest of the heap, right? But on top of the top chunk, you have like this this chunk that we allocated from malloc. So if we want to like use the pointer, right? Okay, wait. Let's say I'm gonna print out like what this pointer is. Okay, so let's say I do the malloc, right? And you can see that this is our address, right? That's returned from malloc. So if I go back to GDB and I do this, like to see the view, right? You can see that our pointer is this number over here, right? But the heap, the chunk itself actually begins hex 10 bytes before the actual pointer that was received. Because hex 10 bytes, the hex 10 bytes before, right, it's gonna be like the previous size header, and then it's gonna be the size of the chunk, and then after that it's gonna give us like the actual like space for our user stuff, you know. So yeah, and then let's say after this, right, I want to free the chunk. Wait, what? Oh shit. So it's gonna do like the malloc again, and then let's say we free the chunk. You can see over here that inside the bins, bro, what? Inside the bins, right? You have this Tcache bin, and it's especially for the hex 110 chunks, right? Okay, why 110 though? Because the whole chunk itself, right? You have the hex 100 bytes that you requested for, and then it adds a hex 10 for the actual like metadata chunk, right? And you can see over here that there's a pointer inside the bin that points to this first chunk over here, right? So now let's say instead of freeing just like one chunk, I have like 2 chunks over here. So it's gonna allocate the 2 chunks, right? You can see there's this first chunk over here and there's this second chunk over here. If I go into the GDB and I do like this visualization, right? This is our pointer 1, the pointer 1 chunk, right? And then there's this yellow chunk over here that's our pointer 2 chunk, right? Okay, now let's say if you remember the order that we wrote the free in, it's gonna free the first chunk over here, and it's gonna free the second chunk over here, right? So yeah, it's gonna do that. And if we look at heap bins over here, right, you can see that instead of it being the pointer and the pointer 2 in the chunk in that order, right, because we freed it in pointer 2, pointer and then pointer 2, the pointer 2 is going to be at the head of the bin, right? So it's going to be the first one in the bin. And then the next one in the list is the pointer, the first pointer that we freed, right? So yeah, it's kind of like a last in first out, kind of like a stack, but for like the list, right? And if you take from the chunk again, right? I mean, if you allocate again, okay. So I'm gonna like go back to freeing. So over here we have our like free chunks in the bin already, right? It's already in the bin. And let's say we're gonna do another malloc, but for the same size. So the first one that we're gonna malloc is you'll see that instead of taking from like the top chunk here is still the same, right? Instead of taking from the top chunk, it actually takes from the top of the bin. So whatever that was in the first like part of the bin, it's gonna take from there, right? And you'll see that now the count is like 1 in the bin, right? And if I allocate again, you're gonna see that it's gonna take from the bin again, and now the Tcache bin is empty. Yeah. So yeah, kind of that's how malloc works and free works. Yeah. Great. So any questions? Kind of. Yo, Chihong. Chihong. Okay, yeah, what's up? Wait, what do you mean? Like, wait, here.
Anyone else has questions?
AES is called when you are AES is used to encrypt the plain text document. Yeah, but it's the key. So I guess the key is wrapped in the RSA. Yeah, I know. The RSA OEP is just the address. Yeah. I guess it's misleading name more honestly. So the way you have to pages of random 32 bytes. This was the random 32 right? And then we also encrypt it, but not say using AES. Mostly right, the encrypt AES. Any other questions? That's not the variable. Unless you're telling me that this will eventually be cost, it will be like encrypted AES. You wrap it up, you wrap both up. Okay, you wrap this thing for the which I wait, what? It's not sharp, wait. Where's the sharp 256? Oh my god, online study bro. Yeah, I still got ECG carry. So it's one month now, are we done for? 22nd July is our 22nd July is the day before our exam. So I guess yeah, 1 year.
What is the date before exam?
22nd should be a Sunday.
July?
No, August. 22nd, oh yeah, 22nd, yeah, 24th is our exam week. For 2 weeks.
But we only got
Yeah, basically, but we don't know when it is.
then assume it's 24th. But this is scheduled.
Hopefully it's the last day. Huh?
When does your exam start?
We don't know yet. We don't have the timetable. We only got 1 exam.
Only got 4 weeks. Only 4 weeks.
No, if they put ACG last means we technically got 6.
That sounds good.
That sounds good, right? You pray,
Why not? Please September. Please September.
The MSc weeks are longer. I probably only have like a few tests with them.
Papa Kalon is exam week, right?
Exam.
Oh. Yeah, yes.
Huh?
Belt Aki.
Oh yeah, he's the MC, right?
He's not the MC.
He's not,
I think he's the MC, sorry.
he's the MC, bro.
It's my team.
When's the CS?
They say like, yeah, it's the
24th?
the 31st August.
What do you mean? You say 24th. Would you even tell us? I think we just tell the entire class.
Yo, for the T-cash, right? What's the difference between that and let's say Chaba? Because this one is like 11.0 space 2 buffer.
Yeah.
Then for T-cash it is malloc, so it also like allocates let's say 0.30. So but then T-cash it takes from the heap.
Yeah, it's from the
But this one takes from the stack.
Yeah, this is
So
from the stack.
what's the difference?
So they're different like memory regions, right?
Yep.
Over here, you already know how big your buffer is gonna be.
Okay.
So it puts it in the stack.
Mm.
But for heap, basically it's like when you don't know like how big it is, right?
But then you already like you assign a space type, like just now you say 0 extra.
Yeah, but like malloc is like it's just used for when you don't know what the number is. In this case, yeah, we know the number, but it's like if let's say you get the number at runtime,
Yep.
and then you can just pass it to malloc. Yeah.
You get a number at run time.
Yeah.
Oh, okay, I see. And then you like dynamically adjust to the size.
Yeah, that's correct. That's correct.
Great.
The north is used for all those.
I don't see an orange here.
What are we doing?
The north is used for all those.
Yeah? What is the project generator?
What are we doing now? So it's just we ask questions.
Yeah. Just to clarify a bit. Actually, I came a bit late. Didn't really miss much regarding that season.
You didn't.
So it's just a region of space, means the stack that goes up.
It's basically like a region of space.
So I was just
Yeah, and like the business and stuff. I think you probably know already. Sounds like you know.
I do.
How come you buy the cup type V2?
Say again.
This one. You know the cup type V1, right? You can actually support the front thing.
Front thing? What do you mean?
Like you see the pins here?
Yep.
Had like a little slot at the top where you could insert like to change it. So it interfaces with the metal 2-pin thing.
what the hell?
So you could change it to a 3-pin Euro.
I didn't know that.
Yeah.
Because I brought it from China, like it kind of matches with my laptop. So it's both a laptop charger and a phone charger.
Matters of character.
Holy.
I wasn't able to solve my own, so I asked. If P5 coded it, it's probably also 5 coded. Yeah, I knew it. Yeah, I knew it.
Wait, you do CAD? You do CAD? You do CAD?
Actually, what's the point of
Huh?
having
I don't. I still don't. I don't.
He pushed the challenge by the way.
Huh?
Sean pushed the challenge.
Oh.
like it's a five, not
Oh yeah, wait. Can you guys see if like on the website the challenge is out for this like it should be called infant hip or something.
Yeah.
Do you get everyone to install Jeff?
Yeah.
Man, I should have been here to get them to install Pony Debug. Wait, why
That's
didn't you
what
get
I'm
them to install Pony Debug? Why you
That's
let him?
like,
Why you
I'm
let him
lazy.
like indoctrinate them into Jeff?
Infant heap.
Also, I need to one day install BlahajCTF.
Oh, I do. I did. I got my codex to install BlahajCTF.
Wait, I have one way to set up both Pony Debug and BlahajCTF.
I did get my codex to do that.
Wait, just
This is
source
one
the
of
phone unit. I mean just source
I mean,
the
yeah.
okay whatever.
It is 1,000.
I know because I didn't want to deal with installing
Whoa.
it.
So codex install BlahajCTF
Yeah.
with Pony Debug.
Okay.
Yes. I was like, man, I can't be fucked with it.
You know what would be pretty cool? You can have like a completely AI hallucinated OS. Like the LM keeps track of everything, your files, your comments. Like when you type in a command, instead of going to the kernel, it goes to an LLM and then LLM has to generate the output.
Yeah, that's called OpenAI site hydration.
It'd be pretty cool actually.
You know how people do server side hydration these days with JavaScript? Because JavaScript is too trash.
It's like the AI, you know, a long time ago, you know, the AI Minecraft.
Yeah.
It'll be like that as well. I can agree with you.
You can probably just try like talk to your ChatGPT and ask it.
Yeah, but you need to optimize it, fine tune it to be a little bit.
Who's gonna waste the more IP to find you?
Every day for 4 weeks.
Put it in the pie.
Is your coordinate or just like find the binary? You have to support.
Huh?
Oh wait, yours is not.
It finds the binary, but
He's using the Sasha like.
Wait, so am I? Because you told me to install it.
yeah.
And it's like, that's
Yeah. Wait, like it finds the binary, but I feel more comfortable providing it to. Yeah.
Like I basically I forked Pony in it and I told Codex improve this. So I implemented the like I told Codex to buy the raw of Apache.
Which ones have you
that
tried?
doesn't help with anything. Does it?
Wait, and mine has a backup. Mine also Debian repositories.
Yeah, there are a lot of missing.
Okay, well, the
Because
vulnerability
Launchpad
here
keeps
is
on
like,
going down.
Yeah.
you can see in the compile instructions it says that what this means is that the stack is executable, which means
Wait, did they know this?
whenever you put instructions, you can put your own text onto the stack, right?
How many heroes
So
do
you
you
can
in
jump to
society?
there and you can run that.
How many more heroes do you in society?
So the purpose of
500 notepads.
because there's not enough block gadgets for you to get bin as right? You have to put your own shellcode onto the stack and then jump to it. First you need to start by writing shellcode. So you have like a soft script. You need to create a soft script. Wait, you weren't here last week? Oh, so you didn't do any like challenges? Okay, then you should start from the first challenge. Wait, you posted the slides, right? Okay, yeah. You should try watching the video that he posted so that you can like
Oh,
get
the size header starts from 290.
stop.
Yeah, oh, that's true.
Should be important.
Yeah, so they're trying to say.
Or something, or like somewhere else.
Really? Not that one, bro. That one. Isn't that one a troll? Isn't that one like a joke?
Yeah, you're not teaching it right.
Teach me a Julian.
Yes, like someone here is using it.
I don't know if that will.
He's doing it.
How many GBs of anime goes? How many gigs of anime goes?
How's the heat? Yeah, how's the heat?
Okay, so it's kind of like instead of you know how Ellipses
Yeah, it's crazy.
so it's gonna be
I always thought that was so true.
It exists.
But then, but the basic functionalities are really
it's kind of like this region, and then there are like multiple slots for like any allocation.
No, Kali.
But instead of it being sequential, it's gonna be like randomized. So it's gonna pick one of those slots.
So you have like different pages.
There's like different caches.
Oh, so how will you like,
different size.
let's say you want
So
a
like
memory page size like smaller than that.
no, because they'll like divide the slab.
Oh,
into-
divide it.
No,
Like,
it's not that you
it's like buddies, like the buddy allocator.
No, it's not like a buddy. There are different slabs for different slices. So
Or it's like Memcache 150.
yeah, kind of. Like there's like
Kind
a,
of.
there's like a slab for hex stuff.
Like the T-cache.
There's different like caches.
Yeah, it's
like
not a cache.
So are we going through Symphony?
I guess he's not teaching us. It's okay, we can figure this out.
Okay.
Okay, I'm pretty sure there's like
Okay,
K-Malloc.
guys, lock in.
There's also like the V-Malloc.
Oh yeah, wait. Just to kind of like show you guys what I mean by it is a linked list, right? This is so scuffed because I don't know if this will even work. Oh my god, it doesn't work. Okay. Whatever. Okay, wait.
Do you need me to? I'll do pulling it outside too.
No, sorry. Because if it's too new, the binary is too new, it won't work. It's okay. Okay. So this is the challenge binary, right? You guys don't have to do anything yet. Let me just like show you some stuff, I guess. So basically, just to get used to this program, you can like malloc whatever size you want. I'm gonna put like 256 over here, and then yeah, you can free whatever okay, wait. So whenever you malloc a chunk, right, the edges of the chunk is gonna go to, it's gonna like bro, how do you get PIEVs? I forgot. Okay, wait, whatever. It's like
Just remove your app.
so whenever you allocate the chunk, that the edges of the chunk is gonna go into like an array over here, right? So I specified index 0. So the address of the address is stored in like index 0 over here of this array. Now now I can also do stuff like edit the chunk, right? So if I want to edit the chunk in index 0, what? Yeah, so I can also write like some bytes into the chunk, and also I can read from the chunk, right? Okay. So to kind of to kind of concretize the idea of what it means to have like a free list inside the bin. So you know how when you write a list, what you do is that you have like a paper, and then you're writing like each item like line by line, right? And it's gonna be stored inside that paper. So a normal list you would think of is kind of like that, right? You have this paper, and then you have the item over here, and then as such, right? But what if you had another kind of list where instead of having like one whole paper for all the items, you have kind of like you have one paper, and then on this paper you write the first entry of that list, right? So over here it's gonna say, oh, if you want the entry of this if you want the contents of this entry, you want to go to this page over here. Like let's say it's page 2 or something, right? And page 2 is gonna be another piece of paper, right? Now, if you wanted to insert like stuff into this list, right? What you could kind of do is that instead of like kind of like adding on over here, you change like the first the entry over here to say, oh, I want the first entry of my list to be page 3 or something, right? And then on page 3 you have this other page, and on page 3 you have this little piece of writing that says, if you want the next entry of this list, you want to go to page 2, and then it will like point there. So that's kind of like what a linked list is. Basically, if you go back to the Tcache over here, and let's say I fill up the Tcache, I'm gonna allocate like 2 chunks over here, and then I'm gonna free it like so, right? You'll see that conceptually it is kind of linked into like a linked list, right? You have this list that points to the next entry and so on. But memory-wise, what it actually does is that if I do, you'll see that the first number inside the first chunk of the free list, right? It's gonna be this pointer, and you can see that the address of this pointer is the next chunk in the free list over here. So kind of like the notebook example, you have a certain piece of data in the first page that says the next page is gonna be at this address over here, right? And then you go to this address over here, and it's gonna say, oh, the next entry is gonna be this address and so on, right? But over here we only have 2 chunks, so it's gonna be a null pointer over here, meaning that the list is like terminated, right? So yeah, that's kind of like what it looks like in memory for the Tcache. Okay, so the thing is, right, if we look at this challenge over here, the essential question is, what happens when we can read or write to like free chunks, basically, right? Imagine a scenario where you have like a program that frees a certain address, right? But instead of like clearing the address or nulling out the pointer, basically like setting it to 0 to indicate that there's no more chunks being used by that pointer, right? You actually like write into that pointer, and you're able to like modify things inside that chunk despite it already being freed, right? So if you remember, when we're unlinking from the Tcache, right, is this a linked list over here? Now imagine if we could like write into this this chunk over here, and we change this pointer to point to somewhere else. Like let's say this number over here, right? You'll notice that because we've overwritten the pointer inside this chunk, or what we call the next pointer in a free list, right? We've already corrupted the metadata, and if we're trying to take chunks again from the free list, the allocator is gonna trust the metadata, so it's gonna think that it's gonna take from the Tcache, right? And when it goes when it's going to take the chunk at the corrupted metadata, it's gonna return whatever you wrote over there, right? So to go back to the program, you're gonna want to try this. You open the file with GDB, right? And I'm gonna run it over here. And what I'm gonna do is I'm gonna allocate 2 chunks, right? and I'm gonna free them like in the reverse order because last in first out, right? And right now the Tcache looks like this. You can see that the one that we recently freed is at the head. And if I do this, this is gonna be the chunk at the top of the list. Yeah. Now, if I suddenly like edit this chunk, right, the one that I recently freed, which was index 0, or maybe it was index 1 for you guys, whatever you chose, right? I'm gonna enter some like garbage data here. You'll see now that the Tcache is corrupted because now the next pointer in this chunk over here is pointing to a certain like garbage data, right? If I do it in viz, this was the chunk that we wrote into, right? And the number over here is not a valid pointer anymore. So when we malloc from here, and wait, what was it? Yeah. If I choose the size, we just took out the head point. I mean the chunk at the head, right? And I check the bins over here. You'll see that it could not like display the list properly because the address now at the head is not a valid address. And if I try to allocate again, you'll see that my program crashes, right? It crashes in malloc because what it's trying to do is it's trying to write to the chunk, but it finds that the chunk returned from the free list is like not a valid address, so it fails. And you can see that, yeah, it crashed. So now the question, right, is that since we know that we can cause the program to crash, right, can we like cause it to not crash, right, but still like do something malicious, right? If you remember, like from the first day we did like stack exploitation, you could cause the program to crash because you were able to like overwrite the return address and make it point to somewhere that's not valid memory, right? This is kind of like the same thing. We caused it to crash because we overrode the pointer in the free list. So can we overwrite the pointer to somewhere valid, but that will still allow us to do something malicious or like exploit the program and get it to do whatever we want, right? So this is what we call Tcache poisoning. Basically, by utilizing the fact that we can write into a free chunk, we can corrupt the free list by actually modifying the pointer in that chunk to point to whatever like address that we want to write to, right? So to go back to kind of the example, let's say we go back to the scenario where we're writing into the free chunk over here, right, which is at the head over here. Now, let's say somewhere else in memory, there's a certain address that contains like a secret string, right? And we want to be able to read this string. So what we can do is that we can write into the free chunk over here at the top of the free list. And we can modify the pointer in the first like 8 bytes to be the number that's like the address of this secret string, right? And now you can see that the second chunk in the free list is actually this secret string address, right? And if we take out from the Tcache, eventually the malloc is gonna return the address of that secret string, and of course we can read it, right? Another thing we can do, of course, because we got the pointer from malloc, right? We can also write to that pointer. So yeah, what this shows is that when you have a vulnerability where you can write to a freed chunk or a freed address, we can get it to return whatever pointer we want it to return, and then write to that pointer. And this is called a use after free vulnerability, right? But of course, for the Tcache in particular, when we're doing this kind of exploit, the address that we want to make the Tcache return to us, it has to be aligned to 16. Kind of like in the stack example when we had to get the RSP to be aligned to 16. Basically, the last digit of the address that we want Tcache to return to us has to be 0. And this is for some kind of reason, probably like chunk alignment because like all the chunks in the heap are aligned to 16 bytes. So for example, going back to the heap over here, you can see that our allocation here, it was like a 2A0. And this allocation over here is a 3B0, right? And the last digit is always 0, yeah. So that's just some stuff to take note of. Okay, so for now, I'm just gonna let you guys play around with the program, and you can try to replicate like the idea of making it return a pointer that you want it to return, right? So you can try to write whatever script you want, like using the Pwn Tools library or something, to interact with the challenge over here. Like this binary, you can write whatever script you want to replicate the exact scenario where you get the Tcache to return like whatever pointer you want to. So for now, we'll just do that. Let us know if you need any assistance, help, or clarification, because I understand it's a lot to take in. So if you need any help with explanation, yeah, just let us know.
Set print f.
Any questions? Yeah, any questions? I need to earn my pay. Really? Yeah.
Please do it. Next
Yeah, the nightmare revolution. Or revelation. Oh yeah, well, you can try, but you can try to set it up, but it will fail. I'll just tell you. Yeah, but you have to understand why it will fail. Because it wasn't expecting a non-number. Oh. Yeah. So if you put in a number, it will work. What version?
week. Yo,
So,
can I do a quick check on how to read the heap? Like,
type in vis, VIS.
it says no command.
Ooh, wait. Jeff user, he says this is not a command.
Oh, you didn't install GF extras, like
The
the
one-
command that we sent in the Discord. You need to
No,
install that.
I did. Wait, now let me try again.
You need to install that.
I did this here.
For this specific day, were you there last basic commands?
Wait.
You want to run the line.
Are you using the GF extras? It should be GF dash extras.
This will run it as per line. If you want to
Yeah,
pause it,
run this and just run this entire command. It's GF there.
and then you just like suspend security.
Wait. Now.
For today, wait, have you installed it? Okay, cool.
Okay, that makes sense.
Basic commands. You hit
Sudo.
GF. No, it's not sudo.
Let's try.
Your Arch, right? There should be a package on the AUR. Go search.
Alright.
Unfortunately,
It's like in the announcements, the command. You guys volunteer?
I skip for the first day.
Oh, the first day. Okay.
So I'm kind of the biggest student right now.
Okay. Okay, so for the first day, you don't exactly need it for today. It's a bit different. But
I learned about like stack and heaps and like assembly and we go for lunch and then I leave. So like I don't know how to probably solve a challenge or write a solution.
it's GF extras. You need to search for GF dash extras.
okay.
Because it doesn't come with base GF.
Do you understand the steps?
Yeah.
I'm really
I think it doesn't
Could be
come
good.
out of the script.
No, I think I'll figure something out. Okay, let's try.
It's gonna be Python usually. So the library that we use is the Pwn library. So whenever you write the exploit script, you just do that from Pwn equals start. Yeah, and
Clone
then
the-
from there you can just test it.
It's okay, it's okay.
Yeah.
GF config.
Okay. Do you want me to show you like some functions that we use? So start of the program I always do import. And you do something like basically to set what program that we're trying to exploit. Yeah, yeah. And then whatever the if you want to run the program from the script itself, you do like this process. This runs the program locally. And then to kind of send stuff into the program, you do like send line. Like if you were running the program like and you type this in, this is just same input. It's like input. I think that's all you need to know. If you need any other syntax help, I think there's some documentation in there. You just you can try to read that. Yeah. So you guys all good? Any help?
Still trying.
Okay, okay.
Let me just try if I can use just this one.
Wait, are you the person who needs help with Gav extras?
Yes.
Show me a comment.
Sorry?
Let me see. Let me think. Scroll down. All the way down.
Searching for that.
Can you type in Python 3 for me? Python.
Oh, that's the first.
Yep.
3.14. Do you have the environment for?
Then,
Huh?
then?
Yeah, the UV thing.
Yeah, I do. I can set up.
No, can you enable it? Do you have it right now? Yo, I don't know how to solve.
Wait, I enable the van in which doc? I mean, let's go to the directory real quick. Wait, do I enable it in the directory or? Because I'm not.
No, wait.
Just try to visualize like
Could you open up the install guide?
Sure.
this is stupid.
You're using outdated. Yeah, it's for 3.8 and then they have 3.14 installed.
Wait, how come they have 3.8?
No, the Gav it works on 3.8 because of a library that's outdated.
Oh.
No, the install guide for like that we sent you guys. You know the one with
The
the
Windows.
yeah.
I don't want to code in this entire visualization
so
just for
You guys set up an install guide for all the categories.
Oh.
Inside there, there's a Python environment.
it's too much text.
Yeah, let me see. UV, let me think.
Wait, they can just source the fan factor.
Yeah, where is the vent flow?
Good. Yeah, wait, okay. I think it's like in the home library or something.
Wait, can you go to the Gav? Just search up Gav GitHub. Yeah.
Python.
Did you send the wrong? Did you send the wrong install instruction command?
Wait, no, shouldn't be one. Should be.
Where's your terminal? Can you go to your terminal?
There's the command in the.
Oh. Paste. Give it a sec. Okay.
Cool.
Oh, this not Gav action. Go back. So I use GDB. It's the Python requirement. Didn't say. This is the one that doesn't work, right?
Let's try again.
Terminal.
Okay.
Let me think.
Oh, because you already.
Delete that.
Yeah. Look, so can I see your.
Documentation. Oh, the error.
Compatible. Go back. It's the AST string. Click on. Scroll down.
Yep.
What's the difference?
Let me think.
What does it
Let me see. feel like GIF sucks, man. Seriously?
Can feel.
Where?
So it means I tried to install it, but then it's really
Serious? That'd be a huge undertaking.
No, but just remove the GDB in it and install the deb one.
Wait, let me see.
Alright.
Wait, Polybug, how did they install using?
You should just install the deb. There's a deb package.
There's
Just
a deb?
Yeah.
Oh,
You just install the deb package.
Okay.
All about the non-Ubuntu users. One sec. Wait. Fault pipes. You're on what distribution?
Arch.
Oh, Arch.
I don't think that.
Wait, there is.
There's a Jeff.
There's a Jeff extras as well. There has to be. It doesn't. There's no way. Let me think. 4 bytes.
Batman.
Jeff is for charts, bro.
Yeah, I wrote there Polybug/Jeff. Up to you guys. And then because I love Jeff.
Python all bytes.
What the hell? Doesn't install Python 3.14. Thanks, it still doesn't install. Issue closed. What?
That's crazy. Worst case?
Bro, Jeff relies on a library that was last updated 2 years ago. Wait, I'm gonna make a pull request right now.
Oh, yep.
I don't know if it works.
It's working finally.
Huh?
No, I packed man the whatever package that is.
What package?
Python forward.
Oh!
I packed man it.
You!
Hey,
Okay, can you
try it out.
try installing it now?
Right.
Jeff extras. The command that he
No,
pasted.
this is Jeff Extra. It's done.
Oh, it's done?
Oh, I thought you said there wasn't a package for it.
It's named Python forward.
No, that's not Jeff extra. That's a dependency. You need to still
Yeah.
install Jeff extras.
But the dependency was because like
Yeah,
still-
but you still need to install.
he's installed for Jeff Extra already, bro.
Oh, I don't need to make a pull request.
I guess.
Okay, sure.
Try
Who
to
else
give
have
you
an
a-
issue?
this.
Yes, issues. And then that.
Can you show me the error?
Run. Main is main. Break. This is freaking address. The team has not been initialized. Okay then.
I need to enhance my
One
Docker template.
Okay.
200. And let's do what do you mean the hero has not been initialized? The heat has not initialized. I think I must write it first.
Wait, we kind of see the entire slide. There's not the entire slide.
Wait, what is your program doing? Check it out.
No, basically overriding.
Basically just overwriting the code. So I assign a thing. I assign it to this one. I assign one chunk thing. Some bytes. Then I overwrite something else. That's the so it goes to this.
That's crazy. How do you like?
I don't put anything on.
AI tech file.
And so the idea is that you're able to break it. By breaking it, you're able to only see what. And so what your head is here. So what layout of the head is able to all the way down to but you'll be covering all the very terrible idea for how to chew.
But basically stimulants. So basically just caffeine that's trying to shoot. What? This one is reducible and dialogue. Discord online? Discord online what time? Oh, I only see it one. I just sleep at 1. How are you tired? I'm tired, bro. I need to go.
Get both. How about I just get both?
Get what?
Just get coffee and Milo. What kind of sugar?
Any sugar. More of the
For the brownie. For the brownie. Brownie like coffee. No coffee. Yeah. Wait, so what do you do?
Bruh, I installed gas and now it's infected my phone. I've got my phone debugged against gas. I want to separate it. I want to get for only GDP, but not for only DDP.
Individual is the extension for individual and Jeff are basically almost the same. I mean, except for the commands and the tools. They're both just an extension for GDP. You can delete one honestly.
I don't know. See how first. Go and try Jeff first. I understand how it works now.
My heap is not initializing for some reason. I did. And I did my heap. Then read. I think the heap is not as initialized.
You don't understand how bad. Like when you install it, it automatically does break system packages.
What?
Yeah, break system packages.
I know
Like it breaks your system packages.
like what packages do I check?
No, it's not like that.
How do you even find out what chunk you should put it into? How do you even find out what chunk you should put it into?
Yeah, he's spreading it to me, bro. So what do we do? What about? Oh, bro, there's a coffee. I don't know.
I might low key will see it.
Go home, coffee right now. Really?
Is that all?
About 4 hours.
You need help? Wait, do you need help?
Yes.
You already have it, what? Yes. Okay, wait, is anyone else need help?
Anyone has any difficulties with the GF and then you can
I've understood that stores, when I allocated memory to the index 30 of size 100, it stores it here.
Have you tried to
Allocate another as in, I have another index.
Yo, bro. I am not getting a heat for some reason. It's quite weird. Like if I just do.
Do you have GF extras? This is not GF extras.
This no? I have this no? That's I think that's a different team lah.
Oh no, this is GF extras.
Okay. anyways,
Have you tried to allocate something?
yeah, so okay, let's go.
Yeah, right.
Continue. One, next one, 100. Like,
This.
edit, one, like, 10, like,
Ooh, okay.
okay, then read, one, I don't know where it is, but somewhere. But it's allocated,
This.
there.
Can you try this?
Sure, wait now.
Have you patched the binary with pwn in it?
Pwn in it.
Yeah, because we're using our own version of libc. Wait, quit GDB. And run pwn in it. Yeah, because we're using our custom version of libc. Well, a very old version of libc. Because it's easier to work with.
So
So
what is
after it patches, it creates. You see, it creates a main dash underscore patched. So
I
this
run
is the
that.
patch version that you need to run.
Ah, so what's the error just now? Like, it was a non-compatibility version to the current stack.
The current libc version that your system is using has a lot of changes to how the heap works as compared to our version that we're teaching right now.
But the one we're doing right now is like the basic one, right?
We're
Like,
doing right now very basic, yeah. So no mitigations, no nothing. So it's quite easy to do exploitation. But the more modern versions have a lot more exploitation stuff. So
How do you create this one?
SLR, you cannot specify hard addresses.
alright,
Introduce relative offsets to the function symbol.
cool. Thanks.
But I.YCEP.
Come on. Name plus 52, which is... Okay, central break. And 100, okay, continue, edit, and
Eight bits or why, but here, with eight that's not enough because yeah, it's 1 5 dot.
You should put it in a folder where you won't be able to.
okay, so what does this mean? Chunk is 0. Okay, so this one is... What's at the bottom? What's at the bottom? I have no idea what is at the bottom, but okay, for sure.
There's no flag. And this is the content I put. And then I just did this funny thing. I took the size of one. Wait, is this in like bins or is this in bytes? Okay, so wait, I think I know how to best it. It's bits, it's bytes. Yours is exclamation clear, by the way.
405,280, 405,280. I don't know what this points to, but okay, it points to
Oh,
something.
that's why. What if we ask? I close C sharp. Wait a minute.
So every single thing, every single how fibers until like how okay, whatever, yeah.
No, this is raised by the actual. Okay, no.
So all these are all, I think this is
So you're trying to allocate the size to like each hard pointer for I think this is a pointer to the Will they get a reason? Is Microsoft Angular okay? No, seriously, what's the issue with this? Like GCC, the only reason you'd ever use this is if you're on Linux. This is the best Linux one. No, like it's very Visual Studio, not Visual Studio.
Yeah, so just activate it before you use. So you can like add it to your bag.
So what do you do with this in like
So your goal is to just get
Go for the lunchtime to 8
arbitrary.
it's on our
So basically, remember in the first one lesson we talked about alternatives, right? Arbitrary read, arbitrary write. Arbitrary execution. So arbitrary write is basically writing to places where we're not supposed to be writing to. So that's your goal. So you need to remember what the structure is and the vulnerability, which you see some screens that use something. And try to do it. That's all. What are you using a laptop for? This laptop has one then.
basically trying to do another copy fail, but at a lower scale.
Yeah. Huh? You want to buy router?
I got jack shit. Oh, it's just like codec. It's just codec level. But I don't know what the hell is that. Do you see anything in first class cameras there? That's like jack shit. I don't think
Bro.
I mean, it's a camera store. It might be a camera store.
Wait, life is evil.
I mean, I'm not sure, but like this shit looks so esoteric, right? Esoteric. Oh shit. Hey.
We just implemented dot
Am I even not right with that? No. Liquid is here. Yeah, it's going to computing. Oh, I got place to work. We will ask him.
The road that we walk down last time to the bus stop.
They are very long route.
Instead of going into the
exit by doing
turn right, yeah.
So I don't like to say.
No, you don't go to the bunch of Thunderbolt.
Yeah.
Go that roundabout,
I turn right.
Yeah.
Oh.
Then you walk up the queue, right?
Yeah.
Then on your left is will be a car park.
Okay.
Now on your right.
allocate memory, right?
Now I pull up pop out the Google Maps.
Allocate memory.
Yeah, go Google Map. I'm not on Google Map.
That's OC, that's traffic go. Pull up the OC.
How do we do that? Why the class?
Oh, this is talking about we are here, right? So we always go down here.
Yeah. No, yeah, okay. When we go down, right?
Oh, we always
Down here.
you turn right.
Yeah.
You want me to turn left?
Last time you go down here, you just go. Oh, you can go by plane, right? Oh, you like, you know the canteen down there? You walk to the top one there. You just beyond. Better than walking all the way here.
I can't cut through, man.
Can you? I should know. Okay, how I don't think you can.
I mean, it's not that far away, right? This is already, I can see it on the same screen. It's really not that far away.
Yeah, they can do it.
I pop out see.
So,
Oh god.
I got my phone. This is the time, right?
I got things to see.
Anything about it?
Yeah.
My friends are in US.
No, they're not. But like, wait, is it? I think I need to learn what freaking coffee shop is here. I can't go by here, man. If I keep following through them, like past this store, right? Can I exit out from here?
Father, how do you exit from there? There's nothing behind there.
Oh, I know. Why is the swimming pool here?
Yo.
What case did I walk around?
Quick check for the heat, man. So this arrow means it goes down. It goes down, right?
Yeah.
From low to high memory address.
Can I just talk?
Yeah.
Then why 4052 is here, right? Which points to here, which is some byte of random zeros, and then there's a memory address which points back to here.
That's just like, wait, how big is the chunk that you allocated?
I remember I think just random numbers are like 2, 3, 5 or something. No specific number, because like the moment you go past that, right, the program shuts down.
I'm not really familiar with GD with Jeff. Wait, let me see.
Okay, let's run.
Try allocating, make them the same size lah.
Cool, let's do 5.
Sure.
Okay, let's do one more.
One sec. You need continue. Different index. Yeah. Type in this. Yeah, you see there's no pointers.
So this one,
This is the top chunk, you can ignore it. It's not relevant. It's not ones that allocated. These are the ones that you allocated.
oh, so
Yeah.
so I allocated this one, but it's a heap.
Yeah.
Why is it a heap? Wait, hold up. The chunk, oh yeah, I allocated the chunks in the heap.
Yeah.
Then when I free them, they will go to the bin.
They still stay here. It's just they do go to the bin. Try freeing them.
Okay, so when I think I get it. So like, when they free them, they'll be linked up by the bin, but they're still there. Correct.
Yeah.
Okay, that's 3,
0.
0 and 6.
Yeah.
Free books, free books.
Yeah. Type in this now. So you see they're free, right? So you see here, this one points to this one, right? This one below one. It points to the next, which is this one.
A0.
Because you freed 6, the 6 was the last one you freed, right? So 6 will point to the one that was first freed, which is the 0 one, which is this.
6 was the one I last free. Oh, so it's a. Oh, so it gets appended to the start of the linked list.
Yes. This is the end of the linked list. This is the head of the linked list.
Oh, so it goes like this.
Yeah.
So
Because you freed this one the last.
and then when I want to reallocate,
When you reallocate, it will allocate this one first, then it will allocate this one.
still similar to a set. Okay, so this one.
This
why
points
is
to here.
Why is this pointing to like the middle of this?
This is not actually the middle. This is actually basically the heap, right?
Yep.
The structure is that. Do you have the slides open actually? You have the slides, yeah.
We have a side.
Did they post?
I don't think so.
Okay, never
They
mind.
never
Go
posted
back.
it.
So the heap, right? Each chunk has a specific structure. This structure is you have the metadata.
Yes.
This one is the previous size. It's not relevant. We don't use one. This one's the current size. It says OX21, but the current size is aligned to 8 bits, right? So you don't need to look at the last number. So it's OX20. You just treat the last one as 0. So size is OX20. Then below that is your data. So there's 16 bytes of data. So when you call malloc, right, it returns a pointer to the start of the data, which is here. These parts are the metadata. It contains information on the chunk. So when it points back to the previous chunk, it points to the start of the data part of the chunk. It doesn't actually point to the metadata.
That makes sense.
Yeah.
Then for this chunk, right, like the original location 6 chunk that we last free. So by right. Oh wait, so this is the data.
This is not. This is the top chunk. This yellow part is one chunk.
Okay, so this is the data. Okay,
Yes, because you feed it.
This one is similar because we put like both same size. Both are of size 0x2x, 0x20. So both of them are quite similar. But why is the data of the chunk we just free? Oh, I thought there would be a header.
What do you mean header?
Because like it's a linked list, man.
Yeah.
So
There'll be a forward and backward pointer.
There's a backward one. Oh, it's a double link.
I mean, no, this one should be a singly linked list only. There should be a 4 pointer. So you see, this is the 4 pointer. It points to the next feed chunk, which is this one.
Oh, so the structure of like this block of memory freed up, right, is that the location of next let's say free address, let's say after this one is popped, is in the data section, it's not in the metadata section.
Yes, that's correct.
Because this part is the metadata.
Yeah, because the metadata is already used. There's no space for it to add more pointers.
It's already used per se.
Yeah, it uses to store the previous size and the current size. Because even if the chunk is free, you still need to know its size.
Okay, so there's a metadata, there's data, then okay, so because it's already free, so the original data is thrown away.
Yeah. You're not supposed to use a chunk after you have freed it. Yeah. So what happens if you overwrite this? 4 pointer.
I go to a custom memory address and I can write my own stuff.
Yeah, exactly.
What is it called? Like what shell scripting again?
They'll teach you what to do next.
Alright.
That the indexes are for
So let's say
I.YCEP is
Oh yeah, those guys.
yeah, better than fucking Zara.
Okay, I look at that. Oh, is this really? Oh, you did very fast speed just now.
Right.
When your parents are driving us there, you really very fast speed just now.
Didn't know.
No, I know. Now I know how it's like.
And I mellow like that. And then here.
So basically it's trying to return a size T type. With size T is a big one. What is size T?
And there's a metadata part.
So I'll try to go by the.
Metadata.
But no one defines size T. To make a custom thing you need to define it.
Then I
If it was
run
custom then how would we able to run it? Yeah.
So let's say I write. Then once I
He's the
Yeah,
actual
size that it allows is
So can't just remove. I can't.
pinpoint.
Right.
So let's say I think I really
I thought for the price is just
No, you just need your ID and your needs to be code standard.
ooh,
But
very high.
Go search up Codex Cyber.
You got try.
this guy is a really
Very, very weird. Mine
I might need to kind of jailbroken.
Huh?
Mine kind of jailbroken. My clock has a lot of features.
GPT.
Huh?
GPT.
this part.
Oh, you're talking about GPT. Codex, right?
What's the issue? Because I can ban you, it bans you now.
Maybe this
Oh,
part.
I'm not surprised.
Yeah, so like if you use cloud.
I use clock. I don't know.
charity wear.
My clock ID like kind of.
oh, I do have it.
Oh, let me see.
I
What's nothing
don't want to hear you and you're making too much noise. Shut up. Let's get out.
after I finish
This guy is your backup on kid.
Loops going on.
wait, no, no point
Oh, yeah, like
daily.
Sharpie. Like, I don't know how long ago, but you want to
Or yeah, what if you somehow compress it
Kind of fun, and I'm like.
I know a bunch of
right? Then it's safer to store. And then you create a program that you override it. But technically it's some.
There's something like that.
And I'll be fine.
something like that. Something like that, bro.
Wait, but he got it like.
Something like that.
Oh, you might actually do the edit pen 400. It's possible.
Yeah.
Who's the guy?
Oh, some DIS guy.
Oh, yeah.
Why is the OCP class is the same one? Wait, that's quite crazy.
Expires 2028, or that one, the shit expired.
But it's the same month, but kind of mad.
Bro, look, just fuck it lah. Just do plus and minus.
At the beginning, right?
Bro. That's kind of
I
wild.
log together so when the data initialized, like
We already have a lot of like exceptions. Okay, wait, just for clarification, right? Malloc prefers to have hex 10 aligned. So even if we like allocate only hex 5, it will allocate hex 10. Yeah.
Yeah, I'm going to be director.
Yeah, you try.
then
Malloc, yeah.
I I get these two spaces of space on the heap, and then after that, say I write some like say these two they are then I say I have 306.
Okay, that's something like that. We don't have fire.
Another 5 years.
Then
Never
this
study
part
for cyber
will
yet.
collapse into a metadata. And the within this data section, and then that will be the first the pointer to the next
Actually wrong. Metadata lives outside of your
He actually uses.
but wouldn't that like out your
No, your metadata is already initialized by the time you malloc.
Yeah, OSCP developer.
So actually what happens when you malloc is that when you malloc actually once the metadata here. Yeah, metadata is here.
Yeah, then like
And then when you free, you override you override let's say your content
this guy is
with your pointer. Yeah. So metadata actually not that's right. Yeah.
and actually that's what okay. So let's say free
I don't have that.
Yeah.
I thought it was one guy over here.
Oh, it's cool. I think so.
Then China usually hire one.
Wow, that's two.
I think
No,
that
this guy left first.
oh so it will point to the pointer which will point to the next one which will be now in this case.
Yes, so Tcache will have bin and the bin head will store the value of this.
So then
I free. We have free this.
after you free this,
Yes.
this data will collapse, like you will get pointer.
Okay, so
So pointer 2, then this one will point to this pointer because it's a
Wrong. What happens is what actually happens is that
Wow, it's quite a lot of AI.
have you
Quite
done
diverse.
comparative programming before?
Got more songs than Chai outside.
Okay, makes sense. So I will not go into why we use a linked list, but that's the wrong way to use a linked list.
Okay, sure.
Yeah.
Sure.
So basically what happens is that
Sorry.
instead
You only got like
you break this link.
6. But Alpha 5 level, OSCP.
So it will now be so instead of the head pointing to here, it will now be
Maybe it was a
pointing
mixture of like, how does he get quite scared? I don't go for uninfo this then.
this.
You know, I was planning on changing this.
Okay, this is the whole.
Yeah.
He's a young
So this last first in last out, right? So this one so your newest feature will always be the first one that's wanting to be used.
No, he's going studying in one.
Yeah.
IT.
The reason why we use like this is that you don't need to walk through this.
Oh yeah, like
Yeah. So think about it. If you attend at the bottom, if you want to take the most recent
you
you need to walk through the entire list.
because you don't know like which who points to the
Yeah, because you don't know where the end of the link is. You don't know when it will start.
Alright, so this guy.
So it's highly inefficient. So what actually happens is that you just break the first link, and you link to the new one, and then you
Oh, I
link
think
to the
that's
one.
also for.
So every time you add a chunk, you break the first link. Yeah.
I get it.
Oh, he's the one that voted about Jeffrey. Chose Jeffrey. I think he's the one that might have chosen Jeffrey. Okay, see what you got. AI for. Oh, cyber. ASC symbol. Okay. So, there's no way you can do this. I think it's hiding his cards.
Yeah. We're gonna put a pin card down.
COSCP.
This guy, right? He buys coded.
Oh,
Yeah.
No, it's not one of them.
Charge only charge.
And
yo, this guy better go.
not even my voice.
Lock in. Then whatever.
C4. That's so cool. There's no way. Wait, but he's very able to go to NUS with a 3.87 GPA. Wait, wow. Oh.
So when I perform malloc on that
mobile application development usually little function. Yeah, I mean it's kind of
Anything beyond that, we don't get one exercise. So we call that the wilderness.
Tencent is I don't know what
It's called like Roblox. Voila, bro.
okay, like a secondary school student.
When I tried, we should find someone child following. Then we slowly do it.
Oh god. Oh god. Ooh. Oh, wait, what's this? Like a short stint overseas. Yo, 2023 bro, I started. Oh yeah, what he told me in 2018, it took him 5 years to get it. Oh, wait, maybe he might have it. So that's maybe more letter, right? Fine, so 6 years. Okay.
and then Mel
Did you see what I just did there? I just freed
So
when you free the child, then you can still read the child. Right?
Wait, but he's way older now.
What is really actually the pointer?
He went to
That's a great question. You can see now you have a child.
Yo, he went to lower poly.
Which one is it?
you fucking
When it's reading the
it's in front of security.
what is it?
Was that what it's called before?
Removing the stack pointer and then removing the key part, or is it not removing the key and removing the pointer?
I mean, I see you secondary school, I don't know.
Yeah.
So the pointer becomes
Sorry.
Bro, all the stuff like 1 month, September, November.
So you have to somehow explain that.
Oh, he's a oh, it's cool. Wait, is it the one you pay for?
I planted this
I put actually the
Something like that.
wait, what's this?
It actually doesn't print out because it's not valid ASCII. But it's printed, it's not valid ASCII, you can't actually see it. So you need, so that's why we use pull juice. So because pull juice is able to read directly from the terminal and get the output.
You can put actually the I don't know. Is that real? Oh, I have this.
Which isn't valid.
Wait, I don't have. Wait, no, it's not. It's not what though. I also have. I don't have that. What is wait, what? He ran it back again. Wait, no.
Wait. Wait.
Oh.
There's one teach. Why you always think I fall easy before you can. Oh.
Wait, son.
Oh no. Oh no. Oh no. Oh no, I'm so bro. If it has the practitioner. I mean, I'm sorry.
You know a link to this right? The pointer
No, I did law and 7 other why don't we just work on offset? You don't have to fucking be you're gonna work offset, bro. They laugh at you.
Bro, apparently, yeah, bro, apparently Jeff, right? Jeff has a, he has a friend that works on, he was like, bro, my friend did all that shit, and now he's working on
I just copy paste, right? I just,
Now, bro, everybody has
I miss this school. Wait, what else?
Can't even. Don't tell me no, I know somebody else. Okay, no.
Okay, yeah.
Oh god. Don't tell me you graduated last year.
Yeah, and then comma.
Yo, I figured out what's Environ B. I was like reading through the libc and see what I found. I saw
Scientific. Oh, he's smart bro. Scientific community. Chairman of NCO. Yo, fuck off, man. They just go private, bro. Fuck off. I mean, you earn more lah, but like, you earn fuck tons of money. Why is to take a intern? He has way more experience, bro.
What else?
Bro, that's smart, bro.
What do you do at LDG?
He got that do
And let's see how hard is it to get
bro. LSE is fucking hard. After this now, it's fucking hard to get.
Going from global poly,
you get it, and you get in, and you
I somehow find when you ban all.
my first year.
So what happened?
Yeah, he worked at
GPOF. Okay, but I just removed the stack.
He's a cert.
Probably kind of.
Yo,
Yes, he's on the advisory board of GIS.
wait, that's the
Oh, they never see mine.
Oh,
Wait, we did it? Huh?
really?
I mean, I guess, like, yeah, you need to. You cannot teach them Pokemon second one.
Same thing, why is the gap between CH and SCP so big?
Obviously got picked up already.
Yo!
And that's game, maybe China just to go like
China lying to us.
China say half a year ago. What?
I beat all them. I'm faster than them by like a few years.
Is it all because of China?
Wait, no, wait, but you see, the moment after he got his OSCP, the next 4 years, right, at least every half a year.
When you print it,
So maybe the biggest one is from CH to SCP, then or the other offsites. Oh yeah, yes.
So you got eat, yeah.
Yeah, I did. Handsome guys, yeah, come on.
You did all that, then you run it up on the shelf. Then you get on the shelf. How do you run it? Do you make straight?
Yeah, I think
Is it possible to just run it?
Play free Reina. Play free Reina.
No. Wait, I don't have
Am I supposed to like fill out the feedback?
you just got a shell.
Am I supposed to just fill out the feedback?
No, feel like
all
dollars.
random bullshit to make sure that you run understand. So I'm gonna assume
Have the electrical certs also.
can I see your source code?
my source code.
Yeah.
I might exploit.
Yeah.
You got two sheets.
I'll copy paste it.
Yeah, the same. GCSS and CCU.
Bro, wait, where's the guy that? Bro, LSE can make fun of money, bro.
Thanks, guys. So, your code.
My dad's friend. LSE.
Economics and so what kind of school is that? What do they specialize in?
They specialize in economics.
Oh, you.
He could have made much more money, but bro, when they go those suburbs.
So there's nothing.
Well, how's the transition from that to those cyber?
No, that means that there's nothing and you get zero. So what we enumerate is all of them.
We don't have this guy.
Yeah, you did prove that. That's
We don't have this guy.
also,
Wait, what? See you next Saturday. When the gaming comes up, let me know.
Audio sorting.
The people in Bali could have gotten 300k
A year.
I don't know.
That's higher because there's no bonus.
I don't think so.
Yeah, lor. But who is this?
Yo, is it freaking funny, bro? I just this O.S.C.P. what the sigma.
What source does this guy have?
His O.S.C.P. plus, that's aura.
He has OSCD plus.
Bro, that's aura. I mean, bro, wait, that's a picture, bro.
Wait, go down.
Anime girl.
He actually got a cert.
2,900 followers. Excel god.
What is that?
Not put on the model. This one, is it Excel
Yeah,
god?
does Bro actually have it?
All the
Yeah, but the thing is, right, if you want to
To get
Oh, that's legit. Bro.
Is it legit?
This is Dave what? He's the good friend, look at what the arrow pointing for.
I like imagine imagine getting OSCD and just making a shit show of it.
So shit post.
Yeah.
That's kind of aura though, I can't lie though. Wait, that's no key. I can't lie. Hey, you sell the can do so fast genuinely 1 month.
Because it's just a plus, bro.
What's that of plus?
Yeah, it's just a plus. The plus
I
is
also had
like
escape DM for extra
Oh,
bonus.
damn.
what?
Wait, what?
Still cannot believe it. This guy putting
Nano can do this?
he does not have his prop picture and prop picture anime girl. Look at that.
Nat for
大炮
long and range.
outfoul. That's my outfoul, bro. Oh, you Griffins. Oh, it's only W can play foul shell.
Brian, previous guy. Previous.
Solo president.
I read before. All the race.
So your
Like that, man. No, I mean, I get okay, because
So what is this old sick shit?
at the very end, at the B.
Never thought you could do. So just writing the song. What's this?
Say again?
Oh, your notes.
That's notes.
Yeah.
I'm a slow learner.
Oh, you configured your. How do you configure your engine?
The default. I can't be bothered changing it. Yeah, just Nvin init. Screw it, looks good. Can.
Engine init?
I spent like 1 month rising my desktop and then gave up. I just download .shells as
So
well.
much free time.
Sorry, Archie. Yeah, I feel yeah.
I'm also an architect.
What did you mean?
bro.
Oh, this is the
He
KD.
literally just got his diploma in 2020, right? Then he went to study diploma. Then he became a lecturer. Then he became a
Can't be honest. Last time I tried, I used the number. So it's like
Something.
He usually graduated and just became a
because
lecturer.
I took some script from online.
Yeah.
So I was like,
Some.
Just imagine you and me graduated and then you're working alongside each other. That's what the truth is.
you know the pay actually kind of decent though.
Yeah, I don't know.
Like dude, there's like what part-time lecturer 200 per hour.
Oh, it's higher tech as well. Oh, so who's your SOC? He's Griffin's final boss, bro. He's the teacher managing us.
Yeah.
Oh, shit, bro. Hey, bro, but look at this, right? He got his diploma in 2020, right? Then he got special diploma, he became a lecturer.
How is this half?
You want to try now? You want to try now?
Is he even allowed to do that?
I'm fucking low, bro.
It's like imagine I teach you, right? Then I'm working a junior, then I teach my junior, I become the lecturer of my junior. He got EHE, bro. He got his diploma in 2020, then he became an adjunct lecturer.
And then what about
What?
You low key can.
Like if you low key like do well, they low key ask you to like contact the teacher.
How the fair?
Apparently like one of my teachers told me that there was a guy that Yongfil, right? I think you're talking about this guy that was like that asked you. No, different guy, Because I asked to come back.
But he was working.
You're running Windows.
No wonder the shit got crashed.
No, you should run Alice.
What if stack and what if stack?
How powerful.
It's only for 5 months.
What?
Still can put meat. Crazy.
Trivial memory exhaustion.
I'll put it, okay. Malloc, okay. So it starts at 0, okay, press enter, please. Good, send another key.
Something no
You always buy SP for possible.
What is this AIS not CFP?
Okay.
You got OSE Let's start with OSE.
Actually, a quick question lah. Okay. So this one is like, let's say the memory space allocated to like a function. Yeah. Currently, and this time we don't need to. So there's something over here. I don't know what it is. Then this is a heap. This is no memory address. Memory address. Heap goes this way. Stack goes this way. Stack decreases. Actually, for this whole thing, right? It's unique to a function, right? Because I know like
No.
Wait. How did that work?
All the stuff unique to a function is just
This might be
but
I
the
don't
whole thing is
know.
unique to the function.
Because
Don't put it in his
from what
name,
I
government
understand,
name should
let's say we
government.
have a function main, it calls bound.
Oh, I don't understand.
Bound.
So he's working for the
bound
same
we call like but for bound, it initiates a stack with overflow, then this data goes back to main. But main also has its own like this whole thing. So does this like memory space, is it like unique to the function or
No, it's not unique to like
What's
the
the
function is
function?
just like whatever.
Okay, put CK that makes it look worse.
The context is stored in the stack, right? But whatever function it is, the heap is still like shared.
so the it's shared among functions?
Yeah. Like the whole memory space is unique to the program. The program itself, but not the function is all like just stack. Yeah.
So even for like let's say main calls bound, okay, let's say just you do two main calls bound. Then at bound,
Yo, he's actually
both bound and main share. Then actually, if they share the same stack, then why do we need to like? Then why is when bound it finishes and then you return back to main, it pops memory address from the stack. Because my intuition will tells me that I thought this would be two separate chunks. Then they're like independent. So when this one is finished, this one you know where to jump back to. So you'll be wherever the program.
Oh my god, it's legit.
But currently right now, they
Really can.
Less than a year.
Okay, like no. It's more like the stack itself is really quite huge. Yeah, but parts of the stack itself are allocated to each function.
Oh, wow, I cannot take it. It's long already, bro. Too stone.
from stack goes downwards, then maybe this part is so let's say this part is originally was main is this part. Then let main calls bound. Then bound let's say char allocates like 30 characters, 0x30 of characters.
Then when
Wait, he was OG, bro.
but this is a stack.
I
This
just
not
thought he was
this not the
OG.
score. Not the function flow. So
This guy doing
when this one over from this
Oh,
the
you're really
R
fucking.
no lah.
Zero, bro.
This guy not even 1 year.
I'm taking my first breath.
And this guy doing CA.
I thought he just put it all into one. He don't care about it. He don't care. He just knows like, he just don't care.
Yo, lunch is ready. If you want to go down, you can.
We study. Who's this guy, bro?
How long before he took my
Yo, John Cyber.